Okay, guys, welcome back to my YouTube channel. Again, this is your Sadiq Santos, Santos Abe, Santos Bay. Guys, what I have here in my screen is the uh, logic, control logic program, and the corresponding graphical presentation of this. So we can say this is our graphics, BMS graphics. Okay, now actually this graphic was done by one of my students, and shout out to Ray Asopardo. Okay, now guys, what you can see in the graphics, okay, now there are some monitoring points here which are not considered in our control logic program, like this operator enable. Okay, now this operator enable is the let's say the operator can interrupt or can control the start and stop of this equipment. Let's say it is running, then suddenly maybe the operator will decide to stop it because for some reason the operator can stop it in the BMS workstation. Okay, so that is the purpose of operator enable. Okay. Now I have also one here, time schedule. Okay. Now time schedule, actually for the time schedule, this is the automatic starting of this system or in a specific time of the day. Okay, now maybe you can schedule, let's say you can schedule a monthly testing for these funds, so you can do the time schedule. Okay, so if you specify the time schedule for this at that specific time of the day wherein you set the schedule, it will automatically start. Okay, now that is the time schedule. So I have here also airflow. Okay, now as you can see, I have here airflow. So this is the airflow sensing device. Actually, we call this differential pressure switch. Okay, so it will try to sense the differential pressures across the fan. So we have in exhaust and we have in the supply. Then also we have a differential pressure switch that we are using for the bug filters. Now maybe you will not use bug filters here. You can use the pre-filter. Okay. Now, notice the orientation of the differential pressure switch. For the fan, the negative and the positive probes are installed in this fashion. But in the filters, the positive probe is before the filter and the negative is after the filter. Okay, so that is the correct orientation of the differential pressure switch. Okay, so I have to include operator enable, time schedule, then airflow also. Now here, we will just try to monitor the airflow. We will not stop the fan if airflow is not there. Let's say when you start the fan, you are expecting airflow will come back. Okay, so when airflow does not come back, we will not stop the fan because these fans are important when the generators are running. So we will not stop the fan if we will not receive the airflow status. So this airflow status is purely monitoring. Okay, so what other now the bug filters? Okay, I will include that one. But for the bug filters, again, this is just monitoring. Okay, if it is clean or dirty. Okay, what else? Now the press air damper status. Okay, this is for the supply. We have this also. It is also already considered in our control logic. Okay, so what else? Open and close damper, we have that already. Okay, I think that is all that we need to include in our control logic program. So guys, let's say for the generator room, supply and exhaust fan, you can pattern your graphics in this example. Okay, so basically these are the points that you need to include in your graphics. Then if it is if those points need to be generated in your control logic program, then you need to include it. And of course, to be able to run these fans, we need this control logic. Okay, so guys, again, this is the control logic, then this is the corresponding presentation of the equipment. Okay, so we have one supply and one exhaust fan here. Okay, so the purpose of this is to provide fresh air and to vent out the hot air being generated by this generator, because this generator is being driven by a diesel engine. Okay, of course, the diesel engine will generate heat. Okay, so we have to vent it out. Then some generator, they need some aspiration air, something like that. Okay, so I have given you already how you are going to write the control logic program and how are you going to design your graphical user interface or BMS graphics, or you can call this one also as HMI, human machine interface. Okay, now for the graphics, I believe this graphics will reflect all the points generated, mostly generated from your control logic program, and the points being controlled. Okay, so again, as I said, I have to include the points in the graphics. Okay, now why do you need to include? Because if you are going to present these graphics, by the way, guys, when you are doing the testing and commissioning, you will be presenting the graphics to the consultant. Okay, so you are not going to show your control logic program. So the consultant doesn't care about your control logic program. All he needs to do is this, to check the real-time values being represented by these graphics. Okay, so let me share again my control logic program so that I will show you how are we going to include the points in the graphics. Okay, now as I have seen there are some points that I need to include, like for the operator enable. Okay, I will use their simple block like PVB, parameter value binary. Okay, so I will say this one is okay, I will say this one is, I will make it public, of course, because I need to bind it to that graphics. So I will say this one is OP enable. Okay, then I will say operator enable, or this something like control. Now the initial value is 0. We don't need to bind it because this is not a physical point. When we do binding in the control, in the blocks, meaning it is a physical point. Now this one is a software point. Okay, so I will start with a 0 or false value. Now PDB is parameter value binary, so meaning this is a binary. When we say binary, there are two possible values, 0 and 1. Okay, now what else? Then schedule. Now simple block for the time schedule. I can say also, I can use also on the same PVB, but you can use also digital inputs. Okay, but this time let me use this another PVB here. Okay, now this one I will say this is the time schedule. Okay, sometimes you can just say, okay, let's say time schedule. Okay, now again, this is a software point. Okay, now enable and time schedule uh, should be, but for this one, we cannot use the time schedule. So we can use this time schedule operator enable. Okay, then okay, then we cannot use this in an end. Okay, so what I will do here is okay, like this. So I will remove this. Okay, I will remove this node, then I will create another end here. But how I'm going to incorporate this uh, time schedule in my control? Okay, as you can see here, I have here this one. Okay, no, that's the problem. Okay, let me see. Okay, so this one is being. Okay, sorry. Now, okay, let me remove this. Okay, so let me remove this. Delete node. Okay, so I will use here a simple block forward. Okay. Ano, I have to make an AND gate also here, single block. And okay, I hope you are following it. Okay. Now I have an AND here. So of course, I will be checking this one. Okay, I'm going to use this. Okay. Then of course, operator enable, then F1 fire alarm. Okay, so I will use this. I will create a node here. Okay, now as you can see, the logic is becoming complex. Okay, and of course, this one will be connected here. Maski hindi na tayo, maghahanda pa ba? Pwede naman kumain na lang sa labas, di ba? Gusto niya pa bang may handa? Okay. Now, I have some problem there. Okay, so let me go this way. Okay. Then let me, okay. So I included operator enable in time schedule. What time schedule is, I just use this time schedule for testing purposes, okay? Now, of course, the same thing I have to do with the supply pan, okay? So what I will do is, again, okay, for in this one, I have plenty of space here, okay? Now let me remove this. It node, so let me just adjust this one, okay? It's because I'm going to insert somebody, okay? Now, then let me remove it here, delete node. Okay, then I need to use this, I need to use this, I need to use this operator enable and the first operator enable, this one, I need to use this operator enable, okay? So I need to, likewise, I need to add an AND block and an OR block, okay? No, actually, guys, there is another way of doing this, okay? So let me just complete this, okay? So as I said, I'm going to incorporate in my logic this operator enable here. Okay, operator enable. So let me create a node here. Okay, I will create a node here and go somewhere here because I don't want to cross with the, okay. Now I'm including it operator enable. So the output of this, I will feed it here. Okay. So I will feed it here. I will feed it here. Okay. So I can start. Okay. So I can start it with this. But how about the? How about the time schedule? Okay. So time schedule, I'm going to use this one. This is the time schedule. So I will create a node there. But again, I think I need to add here an AND gate. Okay. Maybe the next part, we will try to remove all this. So this is my time schedule. So I'll create a node here. Okay. Create a node. Then go somewhere here. Right. Then, okay. So I need to clear this in the next part or part, I think this is part 6. I will try to Okay. And okay, I will create a node here. I think I need to create a node here. Create a node here. Time schedule. Then this one. I think this is the one. Okay. I will create a node here because this one. And this will be the okay. Now I already considered the uh, operator enable and time schedule. Then I need to consider also the bug filters and the airflow. Okay. So again, simple block. I will be needing here digital inputs. Okay. So let me put all the physical input points here. So what is this one? This one is filter. Okay. Filter status. STS. Okay. Then I need to bind this one. We will see. I think this one we have plenty of 6. Okay. Okay. Then I need to I will copy this for the two airflow. Control C, Control B. Okay. So this one we will use this for EF DPS or differential pressure switch, or you can say airflow status. Okay. Then bind it. Okay, so we bind it to 5. Okay, okay. Then again, I will copy this. Control C, Control B. Okay, so I will say this one is SF. Then bind it to terminal number 4. Okay. Save. Option simulate. Okay, there's no problem. So I can simulate it. Okay. Now, but anyway, I don't think I need to simulate it. Okay, because you have seen already the flow of control. I just added this operator enable. Okay, so but if you want, I will try to simulate. Okay. Now let me say it is on. Okay. Then of course my okay both fans are working fine. So the added logic is not affecting the previous logic. Okay. Okay, then these are the filter. Now you can also create some later I will create some logic here. When are we going to raise airflow alarm in this logic? Okay. So guys, I think this would be enough for this part 6. And I hope if you are new to my channel, you will always try to support this channel by watching, like, share, and subscribe. Guys, if you really appreciate what I'm doing, there is super thanks in my channel wherein you can show your appreciation, or you can always appreciate also all the advertisement being shown in my channel. In this way, I will be able to have something to handle all the expenses that I'm trying to cover up when I'm doing this tutorial. So once again, thank you for watching. And before I will end, God bless us all. Let's all be safe and bye for now.